Hello dear students, welcome once again to the Chemica Point. In this lecture I will be talking about the nucleophilic substitution in ether compounds. First we will look at the reactivity and the mechanism of this nucleophilic substitution, and then I will tell you also a simple trick to form the product for these nucleophilic substitution reactions in ether compounds. Alright, so let us start. So first of all, if we talk about the reactivity of ethers towards the nucleophilic substitution and compare it with the reactivity of alkyl halides and alcohol compounds. Okay, let us look at that. First of all, the reactivity part. Then I will also tell the mechanism as well. Alright guys, so nucleophilic substitution in alkyl halide RX. The formula of alcohol, the simple formula of alcohol can be written as ROH, and then we have this ether compound, that is ROR prime. If you look at these molecules carefully, the only difference between these three molecules is regarding the leaving group ability. In the case of alkyl halide, the leaving group is halide ion. In the case of alcohols, the leaving group is hydroxy ion, that is OH minus ion, and in case of ethers, the leaving group is R prime O minus. And now you must know that the leaving group ability of any group is dependent upon its basic strength. Weaker the base, better will be the leaving group. This is the general criteria for the leaving group ability. Weaker base is better leaving group. Better leaving group. All right. So now the leaving groups are X minus, OH minus and R prime O minus. And if we compare the basic strength, first of all let us make their conjugate acids. The conjugate acids of X minus is HX, that is halogen acid HX. The conjugate acid of OH minus will be water, and conjugate acid of R prime O minus will be an alcohol, that is R prime OH. And I think it is pretty much clear the strongest acid among these species is halogen acid. That means its conjugate base will be the weakest. X minus will be the weakest base. So it will be the best leaving group, and that is why the reactivity of alkyl halides is much more in comparison to alcohol and ether. And now if you compare between the alcohol and ether, that is the basic strength or acidic strength of water and alcohol, the water is a little bit stronger acid in comparison to R prime OH, that is alcohol. And that is why its base will be weaker, its conjugate base OH minus will be a weaker base in comparison to alkoxide ion. And from here we get the complete order of reactivity, that is the reactivity of alkyl halide RX will be greater than alcohol, and alcohol will be more reactive in comparison to ethers. This is the final order of reactivity of these three category of compounds for nucleophilic substitution. Alkyl halide is most reactive, then alcohol, and then we have ether compounds. So this is about the reactivity. Now let us move on. I am not going to talk about the reactive or nucleophilic substitution in alkyl halide and alcohol in this particular lecture. This lecture is all about the nucleophilic substitution in ether compounds. Okay, so let's start. I think it is pretty much clear now that ether cannot participate in nucleophilic substitution reactions so easily, but still we can manage to attack a nucleophile on an ether and form a compound. It can be done in some specific conditions, especially if you apply an acidic catalyst for this reaction. Okay, let's see. So this ether ROR prime, it will not be at all able to react with the halogen or halide ion directly. If you react an ether compound, or in fact for that matter an alcohol with sodium halide or any halide ion, there will be no reaction. You will not get any product in this reaction. But if you take an halogen acid in place of halide ion, if you take a halogen acid HX, concentrated HX, in that case you may get a product. For example, in this case, if you react this normal or general ether compound with halogen acid, you will get two compounds, that is RX, the halide ion or the nucleophile will attack on this alkyl group, and the other alkyl group will leave in the form of alcohol, R prime OH. This is the general reaction for any ether compound in nucleophilic substitution. And how this product is formed, why HX is necessary, halide ion is not capable of attacking this ether directly, but halogen acid can form the product. And for that, let us look at the mechanism of this reaction in ether compounds. Okay, let us have a look at the mechanism. Mechanism of nucleophilic substitution. So I have this ether compound, and the main problem for nucleophilic substitution in this reaction is the leaving group ability of the leaving group, and for that matter I have used this halogen acid. See, in ether compound, chalok, this oxygen has lone pair of electron, so it can act as a base, and halogen acid is pretty strong acid, so this lone pair of oxygen will attack on this proton and halide ion will leave from the other side. Okay, so you will get an intermediate in which you have formed a hydronium ion. There is a positive charge on the oxygen atom, and as soon as we get a positive charge on oxygen, you should understand that it is converted, it has been converted into a good leaving group, because now you can see the leaving group is ROH, R prime OH or ROH, which is an alcohol, and alcohols are pretty weak base. So now it is pretty easy to attack a nucleophile on this particular compound, and that is what will happen. Halide ion X minus, it will attack halide ion, that is the nucleophile, will attack on this carbon, and the alcohol will leave in the form of leaving group. In this way you will get the product, that is RX, and along with this there will be formation of alcohol. And from this mechanism, this is also pretty much clear that in the case of nucleophilic substitution reactions in ether, there will always be the formation of an alcohol which is formed because of the leaving group. An alcohol will be formed and the substitution product will be an alkyl halide. Let us take an example. Let us take an example for a particular compound. Suppose I have this ethyl or methyl isopropyl ether, methyl isopropyl ether, and I have reacted it with concentrated HI. It is being reacted with concentrated HI. Now in this case, iodide will attack this carbon and the other part will leave in the form of alcohol. So you will get the product, that is CH3I, that is methyl iodide, along with the formation of isopropyl alcohol. This is the complete mechanism and the formation of product in ether compounds. But many of you must be thinking, sir, how can you say that the iodide will attack on this carbon only and it will not attack on the other side of the alkyl group, that is the isopropyl group? And that is where the complication of nucleophilic substitution in ether compound lies. Because as you see, in this case I have formed one set of product, but there is possibility of formation of another set of products as well. That is, if iodide attacks on this isopropyl, then you will get the substitution product, that is isopropyl iodide, and a leaving group in the form of alcohol, that is methyl alcohol. How can we say that this product will be the major product and the other product, that is isopropyl iodide and methyl alcohol, will not be formed or will be formed in minor amount in this particular reaction? For that, you have to understand the basic concept of nucleophilic substitution, and if you want to look at the factors which determine the kind of products, the reactivity in nucleophilic substitutions, then you can look at my other lectures in the same channel. Can make a point, if you look at the nucleophilic substitution reactions, you will get detailed videos for this particular topic. For now, I will just tell you that if you look at the mechanism of SN1 and SN2 mechanisms, if you look at the factors for SN1 and SN2 mechanism, then it is pretty much clear that secondary carbon, this is the trick that I was talking about. Okay, the reactions is definitely determined by the mechanism of SN1 and SN2, but if you just want to know how to form the product, which carbon will give you the product of substitution and which carbon will leave in the form of alcohol, for that I am just telling you a simple trick. It will make your job pretty much easier. Okay, let's have a look. And there is only one crux of this trick that I am going to tell you. It is that for SN1 as well as for SN2 reaction, the secondary carbon, if you look at the reactivity of primary, secondary and tertiary carbons for SN1 and SN2, then secondary carbon can react for SN1 and SN2 as well. Both of these reactions can take place on secondary carbon, but secondary carbon is not favorable for any kind of mechanism. For SN1 mechanism, the 3-degree carbon is most favorable. Similarly, for SN2 mechanism, the primary carbon is most favorable. This is the main point, that secondary carbon is not favorable for any kind of nucleophilic substitution mechanism. Okay, now I will make some cases and tell you how to form the product, keeping in mind this very point, and you will be able to form the product pretty much easily. Okay, as you can see, in ether you always have 2 carbons on both sides of oxygen, right? This is the general formula of ether. 1 carbon on one side and another alkyl group on the other side. Let us make some cases. Suppose I have an ether in which on one side of oxygen there is a primary carbon, and on the other side of the ether we have a secondary carbon, primary and secondary. Okay, for example, let us take ethyl isopropyl ether. This is the starting compound and I am going to react it with concentrated HI. And the question is, the iodide ion, that is the nucleophile, will attack on which carbon? Either on the primary carbon, this is your primary carbon, or on the secondary carbon, that is this one, secondary carbon. As I told you, the secondary carbon is not favorable for any kind of reactions. Reactions can take place on secondary carbon, but it is not favorable for either SN1 or for SN2, and that is what will happen. In this case, where we have a primary carbon and a secondary carbon, the nucleophile will attack on the primary carbon through SN2 mechanism. In this case, the reaction will take place by SN2 mechanism, and the nucleophilic part, that is iodide, will attack on the primary carbon. So the products will be ethyl iodide. The reaction has taken place on the primary carbon, and this other part, this secondary part, will leave in the form of alcohol, that is you will get an isopropyl alcohol as the leaving group. This is basically the leaving group. Okay, this is the leaving group, and this is the product of nucleophilic substitution. Product of nucleophilic substitution. Only thing that you have to keep in mind is that second carbon or secondary carbon is not favorable for any mechanism, SN1 or SN2. Let us take another case in which I have one maybe secondary carbon and another tertiary carbon. Second case in which R is tertiary carbon and R prime is again secondary carbon. Let us take the case of tertiary butyl isopropyl ether, and again I am going to react it with concentrated HI. The reaction is going to take place with concentrated HI. Again, look, see the same point, we have tertiary and secondary, and tertiary is pretty much reactive for SN1 mechanism, and that is why in this case the reaction will take place by SN1 mechanism, and SN1 mechanism means the nucleophile will attack on this tertiary carbon, right? So the substitution product will be a tertiary iodide, tertiary butyl iodide, and along with this you will get an alcohol, that is OH, isopropyl alcohol. As you can see, in both cases the leaving group is same, secondary carbon, because secondary carbon is not reactive for SN2 as well as SN1. So this is the second case. in any kind of this, in any question of this kind, you can apply this simple logic. Let us take another case. Let us make another case in which on one side of the ether I have any alkyl group. Okay, now it is not about primary, secondary or tertiary, it is about alkyl and aryl group. If we have alkyl and aryl group on both sides of the ether, for example, I have this anisole. Anisole means methoxybenzene. This is your methoxybenzene. Again, if you apply the basic concepts of SN1 and SN2 mechanism, you can easily tell that any kind of nucleophilic substitution is not possible on arylic carbon or benzylic or carbon on the benzene. So in this case, it does not matter what kind of carbon you have on the alkyl side. Only thing that matters is any kind of nucleophilic substitution cannot take place on the arylic carbon, and that is why in this case the nucleophile will always attack on the alkyl part, right? And that is why in this case, as you can see, the iodide will attack on this methyl group, and as a substitution product you will get methyl iodide. And the leaving group in these kind of reaction in which you have aryl alkyl ether, the leaving group will always be a phenol, right? In this case, the alcohol which is leaving is in the form of phenol. So this will be the product of this reaction. Phenol will be formed as the product in this particular case, as the leaving group in this case. One more case remains which you can encounter is, that is primary and tertiary carbon. Suppose you have ethyl tertiary butyl ether. Now what we do in these kind of cases, because in this case we have two pretty much competitive carbons for SN1 and SN2, like primary carbon is reactive for SN2 mechanism, tertiary carbon is pretty much reactive for SN1 mechanism. And in this kind of cases, bacho, you have to remember a little bit that the reaction or the nucleophilic substitution will always take place on the tertiary carbon. On the tertiary carbon, that is, the reaction is going to take place by SN1 mechanism, and the nucleophile will attack on the tertiary carbon, right? So you will get a primary alcohol along with the tertiary butyl iodide. Now you may think, so why is this happening? Because as you can see in the mechanism of nucleophilic substitution, as well as we have seen here in the mechanism part also, that there is a formation of carbocation plus charge, right? And you must know that the tertiary carbon is more capable of stabilizing the positive charge, and that is why when there is a competition between primary and tertiary carbon, then you have to choose the tertiary carbon. The nucleophilic substitution will take place on the tertiary carbon only, and the primary carbon will leave in the form of leaving group. So this is your leaving group alcohol, that is ethyl alcohol, and this iodide is formed as the product of nucleophilic substitution. So these are the four major cases that you will encounter in the nucleophilic substitution reactions of ether. But I am not saying that these are the only cases that you can encounter. You can get other kind of questions as well, and there you have to apply the basic concepts of SN1 and SN2 mechanism for the formation of product. Okay, I will tell you another case as well in which you cannot decide on the basis of these four cases. Okay, let's take an example of that kind as well, where we get maybe same kind of carbon on both sides. Like suppose I have this compound, benzene, then I have oxygen, and this kind of compound I have, and again I am reacting it with concentrated HI. Okay, now how do we find the product in this case? Because on both sides we have primary carbons. As you can see, this is also primary carbon and this is as well primary carbon, but in this case, as you can see, this is a benzylic carbon, and benzylic carbons are much reactive for SN1 as well as SN2 mechanism in comparison to normal aliphatic primary carbon. and that is why the nucleophile, that is iodide ion, will attack on this primary carbon, on the benzylic carbon, and the product will be benzyl iodide along with the formation of ethyl iodide, ethyl alcohol. So in this way, see, these 4 cases you will find very useful in most of the cases, but in some cases, if the examiner wants to give you a difficult question, want to check your hold on the concepts, then this you can encounter this kind of questions as well. You will have to keep these things in mind while forming the product in ethers. One more thing for ethers, if there is excess of HI, these are the reactions, the products that we have seen till now are formed when you take the stoichiometric amount of HI for this reaction. But if you have taken the excessive amount of HI, you have unlimited amount of HI, then in all these cases, as you can see, the leaving group is formed in the form of alcohol. And you must know, if you have learned the alcohol reactions, then you know that alcohols can also react with the HI or can undergo nucleophilic substitution. And that is why if you take the excess of HI in these reactions, then these leaving group will also be converted into iodides, because these alcohols will further undergo nucleophilic substitution with HI, and the nucleophilic substitution will give you the iodide products. Here as well, in this case also, if you have taken the excess of HI, then this iodide product will be alcohol product will be converted into iodide product, that is ethyl iodide. Okay, this, except only one case. In the case of alkyl aryl ether, it is not going to happen in any case at all. Whether you take stoichiometric amount of HI or excessive amount of HI, the product will be exactly same. And the reason is the leaving group which is formed in this case is phenol, which cannot undergo any nucleophilic substitution. Right? Because benzene is pretty much unreactive for nucleophilic substitution. So even if you take excess of HI in this reaction, there will be no further reaction on phenol, no further nucleophilic substitution on phenol. Okay, so you have to keep these things in mind while forming the product in nucleophilic substitution on ethers. This is all. In the next lecture, I will solve some questions as well which have been asked in previous year JEE Advanced, JEE Mains or NEET exam, so that you will get a proper hold on applying the concepts in solving the questions. Alright, so this is it for now. Keep following this channel for further videos and further information about the JEE Mains, Advanced and NEET exams. Thank you so much for watching the video. Share, subscribe and like the videos. Thank you.